Dad, what's the future gonna look like?
All right, good evening. How's everybody doing? You hanging in there? All right, we're coming to the climax of the show here tonight, and great to be with you all. And I tell you what, wandering around today, seeing all the cool aerospace technology here, so many friends and colleagues from over the years, both at Boeing and post-Boeing, and it is good to see all of you. So thank you for being here. And let's give Cyrus another big hand for putting on a tremendous show. I think this reminds us all of our love for aviation. My love for aviation goes back to when I worked at the Boeing Company. I got the privilege of growing up in the great state of Iowa. Any other Iowans here tonight? No Iowans? How can that be? Well, I'm here with proud Cyclone, and I got to start at Boeing as a summer intern back in the mid-1980s as an aerodynamics technology guy. One of the things I worked on back then was laminar flow technology, 40 years ago. And I had the privilege of working 35 years at Boeing, finished the last 5 years as a CEO, and over that 35 years at the company, I went through a lot of airplane launches, new airplane launches. We're going to see one of those tonight. And one of the things I learned from that experience is that launching a new airplane is not just an engineering feat, it's a human achievement, right? It's something that takes courage and passion, it takes ingenuity, it takes humility, it takes persistence and endurance, it takes the use of the God-given talents that we have, and it requires a lot of innovation. I always like to say that in our world, we connect, protect, explore, and inspire the world through aerospace innovation. That's what we do, right? Now, post-Boeing, I retired about 5 years ago, started a new company called New Vista Capital. Spent the last 5 years looking around the world at the technologies and talent that will transform the future of aerospace. And that search through hundreds and hundreds of companies led me to a company called Otto Aviation at that point. Now, Otto Aviation is fantastic. The technology is more than the technology, but the technology is eye-watering. And this company is harnessing the power of laminar flow technology in an all-new way. Not just to create 1 or 2% better performance, or maybe 10 or 15% better, but 50 to 60% lower operating costs. And although laminar flow technology has been known for a long time, for the first time in history, we now have the computing horsepower, the detailed computational fluid dynamics capabilities, the exquisite boundary layer modeling that allows us to understand laminar flow, the digital manufacturing capabilities, new composite materials, fabrication techniques that allow us to build a smooth airplane, super smooth airplane. All of this coming together for the first time in history to produce an all-up laminar flow airplane that can operate at transonic speeds. Never been done before. This is truly breakthrough technology, and you're going to hear more about it. But it's more than the technology. It's the team. And I'm a firm believer that the most important thing we can invest in is the team, our people. And I've experienced that throughout my aerospace career. And one of the things I love about Otto is the team. I've watched them grow from a group of maybe half a dozen engineers in a hangar to a team that's now 300 people strong, all committed to creating this super efficient, super sustainable, super safe, and super accessible future for aviation. That team gives me great confidence that we're going to be successful. And frankly, looking at all of the teams that are represented here gives me a great deal of confidence for the future of our aerospace business, that our best days are still ahead of us. And I like to say that I think the next decade will be the greatest decade of innovation in aerospace history. Otto Aerospace is going to be right at the leading edge of that. So with that in mind, and as chairman of the board, it's now my privilege to introduce the CEO of Otto Aerospace, my good friend, Paul Touw.
Wow, what a great introduction from Dennis to talk about Otto. So Otto, our mission is to unlock the physics of laminar flow to radically reduce the amount of energy required for flight. And I don't know how many people know what laminar flow is. It's sort of this esoteric scientific idea. Maybe just a quick show of hands. How many people have some basic understanding of laminar flow? I see a couple of hands. Wow, holy cow. You guys must have been reading the papers lately. So I'll give you just a quick tutorial about laminar flow. Laminar flow is the smooth and orderly flow of molecules, as you can see on the left side of the screen here. And it's moving in a very normal and organized way in a very low energy state. But something goes awry about mid-screen. The molecules start to bounce and hit against each other. They actually go into swirling eddies. In some cases, those molecules are actually going backwards, which is not really great. And the energy consumption goes way up in this state called turbulent flow. and to give you some idea of the dramatic rise in energy from laminar flow to turbulent flow, we're all familiar with spacecraft that circle the Earth. There's no energy friction there because there's no atmosphere. If you can get a vehicle to fly in our atmosphere in laminar flow, that energy state, that drag goes up about 1x. Where most aircraft flies in turbulent flow, and the drag goes up by 5x. So the opportunity is amazing. If we can get an airplane to fly in laminar flow, we can take an enormous amount of energy out of flight. And just to give you an example that's probably near and dear to your heart, is your heart. Your heart is obviously a pump designed to push the fluid in your body through your vascular system. And our vascular system actually operates in laminar flow. But let's assume for a second it didn't operate in laminar flow. Your heart would have to be about 4.8 times larger. Your blood pressure would rise to about 240 over 160, and you'd have to consume about 6,000 calories a day. Now, interestingly, you'd also need all the other systems to support that. Your stomach would have to be bigger, your liver would have to be bigger, your bones and everything would have to be bigger. And this is a perfect example why it is so critical to get aircraft that can operate in laminar flow as opposed to turbulent flow. It's a massive energy reducer. So laminar flow is something that's been known by aerodynamicists for years, called the holy grail of aerodynamic design. And why? It's really simple. Most of the drag of an aircraft is associated with skin friction. About 25% is lift, induced drag, but most of it's viscous skin friction drag. And that's the portion of drag that we can dramatically drop with turbulent flow. And this was something that was predicted by a guy named Louis Breguet. That's kind of like the modern day Moore's theory of computers. But essentially, if we can reduce the drag, there's a virtuous cycle that begins to happen. You reduce the drag, you need less fuel. Less fuel means less engine, smaller engines, smaller structures, and the entire aircraft gets smaller. So it's not just reducing the drag, it's also making the aircraft smaller, and you can actually predict this with Breguet's range equation. A 30% drag reduction also means that your aircraft is suddenly going to become a lot smaller, 49% of the size. And with that aircraft getting smaller, combine less drag with a smaller aircraft, and you get a 61% reduction in fuel. It's an amazing breakthrough that if we could harness it, is a total change, game changer. So I get this question all the time. Why hasn't somebody done this before? Well, the answer is kind of like nitro and glycerin. We had neither one until about in the last decade. The nitrogen is sort of the ability to predict laminar flow with computational fluid dynamics. And those algorithms didn't really exist. We didn't have a very good feel for understanding for how to predict laminar flow. It's a highly nonlinear capability. And we've only really conquered that recently. And then those algorithms had to be coupled with huge supercomputers. We've had 2 different supercomputers running for the last 18 months, just refining our aircraft, trying to get it to be faster and faster. So the ability to predict laminar flow with huge supercomputers and the right algorithms, and then you have to combine that with the ability to manufacture these highly precise shapes. And we didn't have that capability really until the stealth program came out. A lot of people ask, why didn't we have stealth aircraft 40 years ago? Well, it took manufacturing technology to be able to build those shapes in highly precise ways with no steps or gaps, and that's what developed stealth aircraft. And we use the same technology to build laminar flow airplane as well. So you put these 2 things together, you have an entirely new era of aviation. And we started about a decade ago to prove that you could build laminar flow airplanes. This is the first aircraft we built. It's a Celera 500. Flew in first in 2017. It was both a proof of laminar flow as well as a flying laboratory. We actually had chase planes with complicated instruments that would follow the aircraft and measure laminar flow on it so we could learn from it. But those two planes would fly the exact same flight, come back and land at the airport, and the chase plane to the left would have burned 127 gallons, and our laminar flow plane burned 27. We knew we were onto something really, really big. So we started working on the Phantom 3500 in 2022. It is a super mid-class aircraft, goes 3,500 nautical miles, carries 9 passengers, moves at Mach 8. And that aircraft unbelievably burns 61% less. Most of the super mids in this area, the most 3 popular ones on a 1,000 nautical mile trip, will burn roughly 297, 287 gallons an hour. Ours burns about 115, and that's that radical reduction in energy from laminar flow. We also are about half the cost to manufacture because we have to carry half the weight of fuel that a super mid normally does, so our machine is about half the size. And that means that it's about half as much to produce from a manufacturing perspective. So you get this sort of trifecta of an aircraft that's cheaper to produce, about half as much to produce, burns about half as much fuel, and actually also costs half as much in maintenance. This is our aircraft in transonic flight. It's the first natural laminar flow aircraft to fly in transonic flight. And you see all the green areas, those are all in laminar flow. That laminar flow allows us to build a much larger cabin. It allows us to fly to twice as many airports. We also fly 2 miles higher at 51,000 feet. And we have also completed all of our wind tunnel testing. And as I mentioned earlier, that the ability to have tools that can predict laminar flow accurately, our tests came out within 1% of prediction. Very exciting for us. We also have been building the machine to build the machine right alongside for the last 2 years. We are going to be relocating to Jacksonville, Florida. This is our new home. It's about a 1 million square foot facility. We were really proud of Florida for giving us $515 million of incentive capital to help build this new facility. But our biggest announcement this year is the announcement of a 300 aircraft order. This is a multi-billion-dollar order. Amazing. It is with Flexjet. They are a super mid carrier, fleet operator. And I am very excited to pull Kenn Ricci out, chairman of Flexjet, to help talk about why he purchased this aircraft.
So first of all, we've been involved with Paul on this for about 2 or 3 years, going back to even the innovation of when this began. And I thought tonight when it said leadership need to be open to new ideas, what this is a new idea. But I think we have to do more than just a new idea. When we see a new idea, we have to figure out how to bring it to fruition. And that's what we've been working on, is how to bring it to fruition. And if you think about one thing, we all talked about laminar flow, about all the technology that goes on here, but everybody forgets the real secret is capital. And one of the things that's important and what's really changed is in the fractional aircraft market. Think about this. We have over 2,000 owners who've bought a share of a jet. And in the past, every one of those owners would have made some decision about what their future jet was going to be and how they would deploy that capital in the future. And so we have the unique opportunity to take those 2,000 owners to invest in what they might want in the future by helping to fund and helping to bring this innovation to market.
Yeah.
Let's get it done.
Absolutely, Ken. So we're going to be launching the aircraft in the back. The lights will be coming up. We've got, I think, cigars and other sorts of nice things back there. So please join us. And by the way, thank you tonight. It's been a great honor to be here and to launch our aircraft. And we look forward to taking any questions you might have in the hangar right across the way.
The future is gonna be awesome.